Welcome friends, this is Atanu Chaudhary of SureSolve. Today in this first part, we'll take up the SSC Sigil solution set 65 on trigonometry 6 from suresolve.com and solve the first 5 questions. This set of 5 problems is a bit difficult, but let's go ahead and see how to overcome the difficulties. Question 1 is, if 2 minus cos square theta equal to 3 sin theta cos theta, where sin theta not equal to cos theta, the value of tan theta is option A 0, option B half, option C 2 by 3 and option D 1 by 3. As the target is in terms of tan theta, we identify the easiest way to solve the problem is to transform the given expression in terms of tan theta and then solve for tan theta. The key trigonometric relation to transform such an expression in sin theta and cos theta in terms of tan theta is sec square theta equal to 1 plus tan square theta. To introduce sec square theta, we will divide both sides of the equation by cos square theta. This is the key action towards quick solution, and the process of arriving at this action is called mathematical reasoning. So dividing the given expression by cos square theta, you get 2 sec square theta minus 1 equal to 3 tan theta. Rearranging, you get the quadratic equation in tan theta as 2 tan square theta minus 3 tan theta plus 1 equal to 0. Or 2 tan theta minus 1 multiplied by tan theta minus 1 equal to 0. As sin theta not equal to cos theta, tan theta not equal to 1. So 2 tan theta equal to 1 or tan theta equal to 1 by 2. Answer is option B 1 by 2. With the right approach, the problem is easy to solve. Let's solve the second question. Question 2 is, if sin theta plus cos theta equal to root 2 cos 90 degree minus theta, then cot theta is option A root 2 minus 1, option B root 2 plus 1, option C 0 and option D root 2. Using complementary trigonometric function relation, we transform first the cos function on the RHS to an equivalent sin function, getting sin theta plus cos theta equal to root 2 cos 90 degree minus theta equal to root 2 sin theta. Now dividing the equation by sin theta leaves only cot theta in the equation, and the problem is solved in just 2 steps. We have sin theta plus cos theta equal to root 2 sin theta, or 1 plus cot theta equal to root 2, or cot theta equal to root 2 minus 1. Answer is then option A root 2 minus 1. Easily solved in mind using complementary trigonometric function concept. Let's solve the third problem. Question 3 is, if a square minus b square multiplied by sin theta plus 2ab cos theta equal to a square plus b square, then the value of tan theta is option A 1 by 2ab times a square plus b square, option B half of a square minus b square, option C half of a square plus b square, and option D 1 by 2ab times a square minus b square. Because of the nature of the expression involving sin theta and cos theta, it can easily be seen that getting tan theta by directly dividing sin theta with cos theta is not feasible. We must take a more indirect approach. In this situation, we apply a generic strategy based on friendly function pair concept. We call tan theta and sec theta as the friendly trigonometric function pair because of the powerful mutually inverse relationship sec theta plus tan theta equal to 1 by sec theta minus tan theta. This expression becomes the key expression whenever the direct expression involves only tan theta or sec theta. So the strategy we adopt here is, as the direct expression is simply tan theta, we'll transform the trigonometric functions in the given expression into sec theta and tan theta first by dividing the equation with cos theta. This is the most important first broad level action for quick solution of this difficult problem. The given expression is then transformed to a square minus b square multiplied by tan theta plus 2ab equal to a square plus b square multiplied by sec theta. Rearrange the terms to create the valuable mutually inverse expressions sec theta minus tan theta and sec theta plus tan theta, getting 2ab equal to a square multiplied by sec theta minus tan theta plus b square multiplied by sec theta plus tan theta. The key pattern here is the presence of the mutually inverse expressions sec theta minus tan theta and sec theta plus tan theta. If only we could convert the coefficients of these terms also to mutually inverse form, we would have to deal with a single compound variable. And that is easy. Just divide the equation by AB to transform it to 2 equal to a by b times sec theta minus tan theta plus b by a divided by sec theta minus tan theta. The second term is now fully inverse to the first. Just substitute p equal to a by b times sec theta minus tan theta and the expression is simplified to 2 equal to p plus 1 by p, or p square minus 2p plus 1 equal to 0. This means p minus 1 whole square equal to 0, or p equal to a by b times sec theta minus tan theta equal to 1. So sec theta minus tan theta equal to b by a equal to 1 by sec theta plus tan theta. Subtract sec theta minus tan theta from sec theta plus tan theta, you will get 2 tan theta equal to a by b minus b by a, or tan theta equal to 1 by 2ab times a square minus b square. Answer is option D, 1 by 2ab times a square minus b square. This is not an easy problem, but still not so difficult after all. Let's solve the fourth problem. Question 4 is the value of sec theta multiplied by 1 plus sin theta by cos theta plus cos theta by 1 plus sin theta minus 2 tan square theta is option A 4, option B 0, option C 2 and option D 1. We identify the simple possibility of directly combining the two terms under the brackets to get sin square theta plus cos square theta in the numerator. And taking one step further mentally, we could see that even the factor 1 plus sin theta gets cancelled out. Let's show you. Combining the two terms under the brackets, the given expression is transformed to sec theta multiplied by 1 plus sin theta whole square plus cos square theta divided by cos theta multiplied by 1 plus sin theta minus 2 tan square theta equal to sec theta multiplied by 2 plus 2 sin theta divided by cos theta multiplied by 1 plus sin theta minus 2 tan square theta equal to 2 sec square theta minus 2 tan square theta. Equal to just 2. Answer is option C 2. The key pattern was to identify the two-stage simplification by combining the two terms under the brackets, and the problem is solved easily in mind. Let's solve the last problem. Question 5 is, if cot theta plus cosec theta equal to 3 and theta an acute angle, the value of cos theta is option A 1, option B 1 by 2, option C 4 by 5 and option D 3 by 4. The given expression cot theta plus cosec theta along with its mutually inverse expression cosec theta minus cot theta forms the second important friendly trigonometric function pair with the result cosec theta plus cot theta equal to 1 by cosec theta minus cot theta. Whenever you get the chance to use this inverse relationship, you will find that the problem is solved quickest. In this case also, the solution is straightforward. As cot theta plus cosec theta equal to 3, this is equal to 1 by cosec theta minus cot theta. So cosec theta minus cot theta equal to 1 by 3. Add the two to get 2 cosec theta equal to 3 plus 1 by 3 equal to 10 by 3. Or cosec theta equal to 5 by 3. And sin theta equal to 3 by 5. Finally then, cos theta equal to root over 1 minus 3 square by 5 square equal to 4 by 5. As theta is acute, cos theta can't be negative. Answer is option C, 4 by 5. This problem is solved quickly without any difficulty. To read the detailed solutions, refer to the article in suresolve.com. Link is in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.